Some people are late, it's okay. Let's just get started with this. What page should we be on in the textbook? We should be on page around 36. Yeah, around 36. Understanding properties would be a good place to be, because I'm going to do a quick revision of what we covered last week, and we'll just start up exactly where we ended the lecture last week. Okay, so I have the code that we had last week right here in Rex Tester. Let me share my screen quickly. Desktop. Okay, cool. So here's where we were last week. Okay, so we had just constructed a class, or created a class rather, because we know that constructor has another meaning, but it was this, if you remember this specific example. So we have a class called person, and we had 3 objects. Okay, so this was called our class, and we had 3 objects that were created from that class. Okay, and those objects had particular heights, weights, and hair colors. Okay, so this is where we were. We had just created this, and we had run into this problem when accessing these various properties, right? We called these properties. Person 1 has a height, and we can access that height by saying person1 dot height. Person 2 has a hair color, and we can access that hair color by saying person2 dot hair color, right? Person 3 has a weight, and we can access that weight by saying person3 dot weight. Okay, but we were having problems with deciding between private and public. Okay, so specifically these 2 words, a property like hair color or weight or height can be either private or public. And we saw that private, we can see in the actual code itself, we saw that private properties, like here we have private string hair color, right? We saw that when we tried to access this here, so if I try to see, let's say console.writeLine person1 dot hair color, for example. Okay, so what would we expect to see here? Person1, this is person1, right? And we gave them a weight, a height, and a hair color. Their hair color is blue, right? We'd expect to see blue here. But you can see when I run this, we don't see blue. What am I? But this is another issue. Identifier unexpected. 2924. This is a weird problem. Sorry, I just typed this up quickly. What's going on? Okay, it doesn't work. Sorry about this, guys. I'm wondering what's going on here. Class person, do I have something unclosed or something like that? Ooh, okay, it's having trouble with 26, 27. What's going on here? Of course, I'm being so silly. Okay, there we go. We hadn't given these types. Okay, sorry about that. So these were public, and private. Okay, sorry, I just typed this up quickly again before the lecture. There we go. Okay, cool. So now we can see that because hair color is private, if we try to access a person's hair color, so if I try to say console.writeLine person1 dot hair color, you can see that we get this error. Okay, it said that it's inaccessible due to its protection level. Okay, but we see when we try to access public variables instead, like weight, those are accessible. So this was the problem we were dealing with at the end of the last week. So there was this issue where I can make, yeah, there are, I don't know why, because now we've switched back. It's weird. But they can always follow with the YouTube video, right? Maybe it's a special day or something, I'm not sure. Because people also aren't posting on the WhatsApp groups, so I don't know. So we've got these two options, right? It can either be public or it can be private. But what this would mean is if it's public, we can change it and we can see it. If you remember that, we can read it and we can write it. Okay. But, ooh, someone has background noise. Please mute your microphone. That's such a mute participant. Okay, so if it's public, we can read it and we can write to it. Okay, whereas if it's private, we can't read it or write it. Okay, and so we want some way to control this more finely. So what if I want to be able to read something, okay, but not write it, for example? Or I want to be able to read it but only and write to it as well, but only write to it in a specific way. Okay, so let's see this again. So you see weight is accessible, but because it's public, it's also changeable, right? I can say person1.weight equals something new. So person 1's weight was initially 70, if you guys remember. And if I can change that to 80, right? And it allows me to change it to 80. Why does it allow me to change it? Because it's public. Okay, so you see it changed to 80. So I'm allowed to both see the person's weight and change it, but with hair color, because hair color was a private property, I wasn't allowed to see it or change it. Okay, because it was private. Cool. So there are a few words that we have to learn in this lecture. So constructor, you already know what a constructor is, right? You already know what a constructor is. You know that public means that something can be accessed inside or outside of a class. Okay, it can be accessed inside or outside of a class. And it can also be changed inside or outside of a class. Private, we also know what that means. It means that it can only be changed or seen inside the class. But it cannot be changed or seen outside of the class. Okay, and this one extra word that we have to learn now, or words rather, is getters and setters. Okay, getters and setters, and they have to do with this idea of public and private variables. So this was just a reminder for what we had learned last time and where we are now. So are you guys comfortable with what we're doing now? So we're just trying to figure out, how do I, for example, take a private variable and make it so that I can see it outside of the class but cannot change it, or I can see it outside of the class and can change it in a specific way. Okay, and the answer to that question is getters and setters, and that's what we're learning about now. Okay, sorry, I know it's strange because we kind of like jumped to a new lecture but hadn't finished the content from last lecture. Okay. So that's why I had to do this quick little reminder, but I hope you guys are following okay. So we have this private variable that we cannot see or change outside the class. Okay. How could I make it so that you could see this private variable outside the class? Someone has some background noise again. I think it's you, Saham. Okay, so how do we do this? So yeah, as I mentioned, the answers are getters and setters. Okay. So we have this private property called hair color, and I want to be able to see the private property from outside the class. Okay, like I can the public one. So you see when I say person1.weight, it's perfectly okay. But when I say person1.haircolor, we're not allowed because it's private. So how could I fix that? So the answer to that question is that I add something called a getter. Okay, it's quite well named. You can also hear it referred to as an accessor. Okay, so getter, accessor, they mean the same thing. So, but what does it do? It gets something from the class. Okay, it gets a property. So it just returns the value of hair color, for example. A getter for hair color will just tell you what the value of hair color is for that person. All right. So how do we create a getter? Well, it's a method. All right, it is a method, exactly like we have our constructor method here, right? This is a method, our main method. You guys know what methods are. this is also just a method. It's a special type of method. So we learnt about the constructor method. It allows us to construct a thing in a particular class, and we also have this these other methods, getters and setters. So let's create a getter for hair color. So we have to make a method because getters are methods. So we would say public. Okay, public. Why would our method have to be public? It makes sense that it would have to be public, right? Because we want to be able to access it outside the class. That's the whole point of this. Okay, so our method has to be public. What will it have to return? Okay, if I want to create a getter for this, hair color, okay, what type would my hair color getter have to return? I want you guys to answer that. What type would my hair color getter have to return? Let me make it full screen so you can more easily see. What type would my hair, push it to the center. What type would I want my hair color method to return? My hair color getter to return. So like here we have void because this method returns nothing. If I was trying to return hair color, what type would I be returning? String, string. Cool. So 2 people say string. That is correct. Okay, so our hair color getter is going to return a string. Okay, we also have to give our hair color getter a name. Okay, the standard for this, the standard name that we give to a hair color, a properties getter, is we take the properties name and we just capitalize it. Okay, so in this case it would be hair color, but just with a capital H this time. Okay, like so. All right. Are we okay with that? So that's just the standard way we name these things. All right. So it's just it makes it easier to read when other programmers look at your code. Okay. And then it's actually quite cool. So it's very simple to make a getter. So you create something like this. You say public whatever type you want your getter to return, and that will just be the type of the property. You guys were able to see that. And the name of your getter. And then if you want it to get, so you want to be able to read from outside the class, you literally just type the word get. Okay, get. You throw down the 2 normal curly brackets that we always have. Okay, and then you just say what property you want to return. So we want to return the hair color property, right? So I want to say return hair color, which is a string, right? So that's going to work because you see it's a string. So this returns a string, and this is supposed to return a string. So now when I want to access this private property, so let's see. Currently, you see I access person1.hairColor. You see hair color with a little h. That's private, right? So when I ran this, it just broke, right? It said it's inaccessible due to its protection level. It's inaccessible because it's private. But when I say hair color with a capital H, let's see what happens then. Okay, so I'm going to change the H here to a capital H. So I'm now accessing the public method called hair color, and the method, the public method, returns hair color, okay, with a little h. And it can return hair color, right? It can access hair color because it's inside our class, right? It's inside the class. Okay, so you see this no longer gives an error. Okay, it's not printing out, but we'll figure that out in a bit. Okay, so you guys can see now that it doesn't give this error. All right. We can create, just quickly, I want to create a getter for weight as well. Wait, did it set it? Ooh, okay, that's very silly of me. Sorry, it's in our constructor. That's the reason it didn't print out. I was very silly there. Bad to copy out code quickly. Okay, and you see it'll now print out blue. Okay, so we're now allowed to access person 1's hair color. Okay, we're now allowed to access person 1's hair color, even though it is private. Okay, even though it is private. And we'll be able to access all the people's hair colors because they'll all have their own, all our objects now have their own getter for hair color. Okay, But now you see what we've solved is I can't change hair color. I can't change hair color. I can only view it. So now you guys probably have heard of read-write permissions before. Read-write permissions. So the idea that maybe you're able to read something like a Word document, but you're not allowed to change it. Okay, you're allowed to read certain things, but not allowed to change them. A good example is any streaming platform, right? If you're on Spotify or whatever, you're allowed to listen, right, or read. That's what we would call it. You're allowed to read all these music files, but you can't change them. Okay, so this is this idea of read-write permissions. So what we've managed to do now is we've made hair color read only. Okay, so if you're outside of the person class, you can only read hair colors. You cannot change them. Okay. And we could do the same thing with weight and height, right? If we made weight private and we made height private, let's see if we can construct some getters for weight and height. So now because they're private, obviously if I try to access person2.weight or person1.weight or anything.weight, it will say no, that's inaccessible. Right? It says that's inaccessible. But if we add the getters, so let's add some more just to see some more examples. So what would weights getter return, guys? What would weights getter return? If I wanted a weight getter, what would its type be? Someone says int, I think. Yeah, cool. You guys are on ball with the type thing, it seems. So we would just say pretty much exactly like hair colors getter, right? We would say public int weight with a capital W, because that's good practice. Okay, and then we would say get, and this time I won't be returning hair color, obviously. I'll be returning weight, right? I'll return weight, so that's a getter for weight now. And now you can see this will still be inaccessible, the lowercase w, right? But I can change that to person2.weight with a capital W, and now I'll be able to view people's weight. Okay, but I'm now no longer allowed to change it. So it's safer than when this was public, right? So you see it returned 75, and that's because when we made person2, we had given them a weight of 75 here, right, for our constructor, and then our weight, and then the weight was set over here, weight equals W, and W was 75 here. And then I could access weight through our little getter here. Okay, and obviously I can do the same with height, and you can probably picture how that would go. Okay, so now let's see. So I still can't change weight, right? So how would I go about changing weight if it was a public variable? I would have said person2 dot, remember, if weight was public, right? This was public. How would I change it? I would just say weight with the lowercase w. And I would just change it to whatever I wanted, right? Like 80. And that would just work. Person2 or person1, whatever object, dot weight, this would just work if it was public, right? But now, because it's private, it tells me that no, it's inaccessible, okay? I'm not allowed to change it still. So how would I go about changing weight? Well, that's what the other word here is for. Okay, so we have getters. Okay, that allows me to read the private variable from outside the class, as we just saw with weight and hair color. And we have setters. This allows me to set the private variable from outside the class. Okay, so let's create a setter for weight. We used get to return the weight. So that's what we used to create our getter. What word do you think we're going to use to create our setter, guys? What word would we use to create our setter if we used get to create our getter? What do you think C# does with this? Exactly, it's very well made, right? So we'll say set, and C# has this special variable that is automatically present with the set class, where you can it's just called value. So you'll just say weight equals value, like so. Okay, weight equals value. All right, so now I'll be able to say, instead of person2.weight with the lowercase w, we now have our little setter here. Okay, set weight equals value. And and I will now be able to say person2.weight with a capital W, and that'll be able to set the weight, and it sets it to 80. You see, and I set it to 80 here. Okay, but now you might be thinking, okay, so person in class person, our weight variable is private, right? It's private. You can see there, private int weight. But now I'm able to both see it, right? Here I can go person2.weight and console.writeLine, and it'll allow me to see the weight, and I'm allowed to set the weight. Okay, we have a getter and a setter for weight now. So we're able to see it and change it. So now it's exactly like if it was public, right? Right? You might be thinking it's exactly like when it was public. So why would I bother now? Why would I have created this private variable if I can now both read it and write it? Well, the trick you see is that in our set method, in this little set for weight, we now control how weight is set. Okay, we now control that. So it's still different. Okay, so with the public, with public, you don't have any control over how the variable is set and viewed. But when the variable is private and you're viewing through your getter and setter methods, you're able to control how the variable is viewed and read, viewed and changed. Okay, so let me give you an example of that. All right, if weight was public, we would be able to do this, right? We'd be able to say like person2.weight equals -50, for example, -50. That would be fine, right? If weight was public, this would be totally okay. That would be totally okay. Currently, because weight is private, this won't be allowed. You're not allowed to go person2.weight equals -50. It'll say you're not allowed to set person2.weight because it's private. Okay, so if I say person2.weight with a capital W, then it comes to our setter class. Okay, and currently it'll still work. It's going to set the weight to -50. But that doesn't really make sense, right? You can't be -50 kilograms. So maybe we don't want to be able to allow people to make their weight negative. Weight has to be greater than, like, let's say 20. Okay, weight has to be greater than 20 kilograms, for example, or 10 kilograms, or 0, or whatever you wanted to make it. Okay, so how would we do that? Well, now, because when we set the variable, we come to this method, we can make sure that the value is positive, right? So I can, for example, I can say if, right? We know what if statements do. You guys are familiar with if statements, right? I can say if, put my 2 curly brackets there, okay? If value is greater than, let's say, 10, then weight equals value. Okay, so now, if the value you're trying to set weight to is less than 10, it won't allow you to change it. Okay, and we can see that. So now, see here I'm trying to set weight. I'm saying person2.weight with a capital W. So it's going to the setter. Even though it's a private variable, we still have the setter. And I try to set it to -50. -50 is less than 10, right? It's less than 10. So our set method is not going to change weight. So you see weight is still 75. Weight is still 75. It was initially 75. I tried to set it to -50, where it went to our setter, which says if value is greater than 10, then weight equals value. Otherwise, it won't change it. So it didn't allow me to set it to -50. If I try 9, that still won't be allowed, right? Weight will still be 75. But if I do 11, right, that's greater than 10, then it changes it to 11. Okay, so was that enough of an example to show you guys why setters are useful? Why we have getters and setters? Are you guys feeling comfortable with that idea? Yes. Okay. Fantastic. Okay. So yeah, can I get added? Ooh. You see, this is why we tried to switch to WebEx, because some people really struggle with Teams. I don't know. Because to me, he's already here, right? If he's typing in the chat, it seems like he must already be in the meeting. I don't get it. Vanille. Alright. Cool. So, we've got this idea. Okay, good. He made it in, because I can hear him. Okay, cool. Benele, you're here. That's good. Alright. So, people are comfortable with this idea of getters and setters. Thelma says she is. So, I think hopefully the rest of you are too. Cool. So, yeah, it's not too bad of an idea, right? We have private variables, and in order to access our private variables, we have to create getters and setters for them. Now, you see, currently we've made weight, height, and hair color, right? And they're all private now. You can see that typing all of this out would be a huge mission. Okay, so let's see. Hold on. C# has a way to do this much more quickly. Okay, I'm just going to tell you where this is in your book quickly. Where are auto implemented? Should have found this a bit earlier, I think. Yes, there it is. Cool. So it's on page 38 of your textbook. Okay, is where these are. Okay, it has a much faster way of creating these. Okay, so you can see this was a lot of typing, right? I had to go ahead and create all these properties, which was a huge mission. I had to create the getters and the setters for all of the things that I wanted to do. And C# can just do exactly this automatically. Okay, it can just do it automatically for you, which is super convenient. All right. And yeah, this is done using, you just need to know the name of them. It's done using what's called auto-implemented methods. Okay, you can see it. It's at the bottom of page 37, but the actual thing is on page 38. Okay, auto-implemented properties. Sorry, I misspoke. Auto-implemented properties. Okay, so instead of writing all of this, public int weight get set, okay, and here instead of writing private int weight, instead of this, you can remove that. You just remove that. You can remove all of this stuff about the weight here. That can all go. And you just say at the top here, public int weight with a capital W, okay, capital W, your two normal curly brackets, and you just say the words get and set. Okay. Here, when we set it, I think we'll have to set it to weight, and that should work. So, yeah. Okay. And you see this now, instead of all of that stuff that I typed, C# just does it automatically for me. Okay, which is quite nice. Remember, because of the test is multiple choice and stuff, you don't really have to know the fine details of how to auto-implement and implement the getters and setters yourself. What you must know is what getters and setters are. Okay, and what an auto-implemented property is. Okay, do you guys feel like you know that? Okay, so you know what an auto-implemented property is. Okay, you know what a getter is, and you know what a setter is. Okay, and you know what the words public and private mean. Is everyone happy with that? Do you have any questions about those particular concepts? And actually, while we're here, also, last week we covered this idea of a constructor. Do you guys remember what a constructor is? The method that has the same name as your class, and that tells the computer how to construct an object of that class. Okay. I know it's all a bit sudden, but we're just concluding last week's lecture still, actually. Those getters and setters we were supposed to manage to cover last week's lecture, but we ran out of time because of all the time we spent on for loops. But everyone's comfortable with this. Do you have any other questions about those basic concepts of a class? So if I ask you about these 4 words, okay, constructor, public, private, getters and setters, or 5 words, constructor again, please. Okay, cool. Let's do that. Let me think about. Actually, there's a good way to do this. So I'm going to start creating a new class. Okay, so far we've only worked with this person class. In your book, they work with a class called rectangle. Okay, so we're going to create a rectangle class. What properties does a rectangle have? It has a length and a width, right? A length and a width. That's it. That's all you need to really picture a rectangle in your head, right? A length and a width. So we're going to create a class that has a length and a width, and a constructor, obviously, so that we can actually set the length and width. Okay, so let's do that quickly. And this will introduce us nicely into the next lecture that we have to do. Okay, so I'm going to remove all our hard work creating the person class here. That's all gone. Okay, all gone. We're no longer creating 3 people. Okay, and this is just the default. When you open RexTester, this is what you see, right? Or .NET Fiddle. .NET Fiddle also works. RexTester now requires you to create an account, so some of you guys might prefer to use .NET Fiddle still, but everything's the same. It's still C#. Okay. All right. So we want to create a class called rectangle. It's going to have 2 properties, length and width. Saham, can you give me some suggestions? What should the types for those 2 properties be? What would a length be? What type would I use to store that? So can you please compile us a list of all the topics we're supposed to? Yeah, sure. This lesson, I mean, I put it at the beginning of the slides. Those 4 words are what you should know from last week's lecture. A double, okay, Saham suggests a double. Is there another, does anyone have another type that we could also use for length and width? Double works though, I think we will use double. Does any other suggestions? Float could work too. Does a length and width have to have decimals, Saham? Or whatever you have in your... Yeah, sure. So today's lecture, the concepts you are supposed to understand are polymorphism, encapsulation, but you see the words are scary if you haven't heard them yet, so we'll see. Yeah, long could work too, depending on how long the rectangle's length and width be. I mean, an int can also work, right? But what's important is that it can't be negative. Okay, a length and a width, they can't be negative, right? That we can definitely agree on, I think. Oh, cool, Joshua made it in, that's good. But we could use yeah, exactly. Basically anything we want, yeah. Well, what would it mean, Thelma, to have a rectangle with a negative length? What would that mean? How can you create a square that, for example, like if we were trying to create a square and its length is -10, how would you draw that? Wouldn't make sense, hey? But we'll see all about this. Okay, cool. So we want to create a class rectangle. Okay, I'm going to call my class rectangle. Seems like a good name for a rectangle class, right? Cool, so that's our basic class structure, already done, super easy. We said we want to have 2 properties, okay? We're going to use the first suggestion, we're going to make them doubles. Doesn't really matter, but we'll make them doubles. Okay, and I think let's make them public for now. Okay, we're going to make them public for now. So I'm going to say public double length, okay, and public double width. Okay, so that's the usual way we created properties, right, if you remember. Would you guys feel okay if I made those auto-implemented properties, so I made them private with the automatic getters and setters? Okay. Yeah, okay, cool. So we're going to do that. So I'm going to change it to private to show that it is a private one with getters and setters, so it's a method. I'm going to make it length with a capital L. And then I'm just going to say get set. Okay, exactly like that. Awesome. And I'll just do the same with width. Okay, so these are now 2 auto-implemented properties. That's what we call them. Right, you know what properties are. you know that auto implemented just means that this is automatically creating getters and setters for these two private variables. Okay, we're happy with that. Cool. And the reason for this, okay, so we've now got a rectangle class, right? We've got a class that has a length and a width. And C# knows what that is, okay? It knows, okay, cool, this is a rectangle. Rectangles have lengths and widths, okay? But how does C# actually create a rectangle now? How, if I want to actually create a rectangle and I want to set its length and width to a specific thing, if I want to create a thing of type rectangle, okay? And that question is what a constructor does. Okay, so we still haven't told C# how to actually create or construct a rectangle object, right? We've told it what the class is, but how does it actually construct an object of type rectangle? And that's why we have constructors. Okay, so our constructor, we say public. Okay, it doesn't return anything, okay, and it has the same name as the class. That's what's important. Rectangle. Okay, like so. Okay, like so. Cool. So someone can answer as well. How many numbers do I need to create a rectangle? How many variables will this constructor have to take in order to actually be able to construct a rectangle? How many variables will it need? Okay, so if I wanted to create a thing of type rectangle with this constructor, how many things do I need? How many variables? Anyone? It's not too difficult of a question. Think about the intuitive answer. How many numbers do I need to represent this rectangle? Two. Okay, everyone's saying 2. That's great. Yeah, I just need a length and a width. That's all my constructor needs to know. When it's creating a new rectangle, all it needs is the length and width of that rectangle, right? What will those types be? What will those types be? What will the types be for our 2 numbers that we're taking in this case? When I'm creating a rectangle, it needs 2 numbers, you guys are correct. But what type do those 2 numbers need to be in this case? In our little rectangle here, the one we're creating. They need to be doubles, exactly. Okay, so it's going to take in a double for the length. Okay, for the length, we're just going to call it L. Okay, and it needs a double for the width. Okay, we'll just call that W. Okay, you could have called them length and width as well. You could call them dog and cat, whatever you want. Okay, it's whatever makes sense to you. All right. And then we just set the length and the width. Right, length equals L, width equals W. I think the auto-implemented properties can sometimes give problems with this, but we'll see now. Okay, so that's what a constructor is. So that's it. That's our constructor done. Our constructor is a method. That is the method in this case. Okay, so it just tells me when I'm constructing a new rectangle object, how do I set all the properties that I need? How do I actually go about creating this? Okay, so that's what the constructor does. Pretty straightforward, I think. Cool. So we've now created a rectangle class. We now actually want to create a rectangle object, right? I want to actually create. We've got this abstract idea now of a rectangle. It's something with a length and a width. Okay, but now how do I actually create an object of type rectangle? Well, we just say rectangle, the name of our class, right? Exactly like when creating a normal variable, you give it the type first, you give it the name that you want this specific rectangle to have, you use the word new, okay, to tell C# that it's a new rectangle, it's a new object, okay? We say rectangle. This is obviously, this last bit here is calling our constructor, right? Our constructor, and our constructor requires 2 things. A length, we'll say is 10 in this case, and a width, we'll call that 12.0. Alright, 12.0. Now when I access this, hopefully the auto-implemented properties don't give problems. If they do, we can always just switch back, but I don't think so. Let's just say rect.length, okay, like so. semicolon. Ooh, did I leave out semicolons? Oh, no, I added semicolons where they shouldn't be. Okay, we don't have is inaccessible due to its... of course. Oh my gosh, I forgot the first rule. Our getters and setters have to be public, obviously. Okay, there we go. Cool, so we now have our rectangle class. Okay, our getters and setters do have to be public though. Sorry, I forgot that. Why do they have to be public? If your getters were private, they would be pointless, right? You still wouldn't be able to get the variable. Okay, so that's the key thing. All right. Cool. So we've now created this new class, and we can go into the next lecture now. Finally, that brings us to the end of last week's lecture. Cool. And this week's lecture, so yeah, Benele, I think I explained in the first few slides quite well, like what you're expected to know from this lecture. Okay, so let me start up these slides. Okay, so this lecture is about two other concepts. They're also just object-oriented programming concepts. You can see there, inheritance and encapsulation. That sounds quite scary, right? But don't worry, actually, because the concepts themselves are actually quite simple. It's very well named, I would say. It's very well named. The words make sense. Okay, and a lot of object-oriented programming you'll see is a lot of it is just learning words, basically learning what all these words mean. So we now know a lot of words, right? We've got getters, setters, private, public, constructor. You know what all of these words mean. Okay, and this is just the same. Okay, we just have two or actually three more words that we're going to need to learn. Okay, and actually quite a few more, because each concept has a few words in it. So yeah, at first I just wanted to revise classes and set up an example, but we just did that. Okay, we've set up this rectangle example. Okay, and here are the four important concepts that we want to learn by the end of this object-oriented programming section. Okay, but in this lecture we're going to focus on three of them. Okay, inheritance, polymorphism, and encapsulation. Okay, inheritance and polymorphism are very similar, are very closely related ideas. So I keep them quite together in the slides. And encapsulation is somewhat separate. Now this might look scary to you at first. Okay, inheritance and polymorphism are totally new concepts for you. But encapsulation, I'm sure you'll be pleased to hear, encapsulation you already know 2/3 of. The words private and public, that's 2/3 of what you need to know of encapsulation. There's only one more word that you're going to need to learn under the encapsulation section. Okay, so yeah, inheritance and polymorphism are going to be quite new concepts, but encapsulation you're already quite familiar with, actually. Okay, so let's discuss inheritance. All right, so it is actually what it sounds like. What inheritance means for just you guys generally. Sorry, I just also want to make sure that no questions are coming through. And also we probably should take a break soon. I don't want to take a break too soon though. Do you mind if we keep going for a little while? I think we'll keep going till 3, let's say. So inheritance, guys, it means what it sounds like. All right, it really does mean what it sounds like. What does inheritance mean in humans? It's like the previous generation leaves something for this one, or it's something that comes down, right? So, or actually even better, you can inherit certain genetic traits from your parents, right? So there's certain things that make your parents unique, if you like, and you can inherit those traits. And inheritance here means the exact same thing. Okay, so, but here obviously we're just talking about classes. Okay, so what this means is that a class can inherit certain things from another class. Okay, a class can inherit certain things from other classes. Okay, so we can set up 2 examples here. We've seen this person class, right? We saw that a person can have a height, they can have a hair color, they can have a weight, right? We could perhaps set up, okay, there's a person class, but there's also a doctor class, okay? And instead of rewriting the whole doctor class and going, doctors have hair colors, heights, and weights, instead of specifying that a second time, I could say doctors inherit from the person class. So everything a person has, a doctor also has. Okay, so a person has a height, a weight, and a hair color. Doctors are people, they inherit from person, so they also have a height, a weight, and a hair color. Okay, get that? So now I can say doctors also have a bunch of extra stuff, okay, over just a general like person class. They do have height, weight, and hair color, but they also have a bunch of extra stuff. Okay, so I still have to define a doctor class, but there's still an inheritance here, right? And likewise with a nurse, I could say nurse also is a type of person. Okay, they also have a hair color, a height, and a weight, and they have a bunch of extra stuff as well. Okay, so that's the concept of inheritance. It's quite simple. And for another example, we could say there's a polygon class. Okay, polygons are just multi-sided shapes. Okay, a polygon might have a length, a width, a number of sides, for example, anything like that. But when we can say that squares are a type of polygon, okay, where the length and width are equal, for example. And rectangles are also a type of polygon where the length and width aren't necessarily equal. Okay, so this would allow you to say, okay, you don't have to redefine every single property. You don't have to redefine length and width. You don't have to redefine hair color, height, and weight. You can just use them. You define these things in the person class, and you can just use them later on. Okay. And C# allows you to do this. It allows for this kind of inheritance. Okay. So that is an introduction to inheritance. I think let's take a little break, and then when we come back, we can see some actual examples of how do I actually do inheritance, perform inheritance inside C# code. Okay, so that's what we'll look at when we come back. Sorry for anyone who was having trouble accessing the lecture. It looks like we're pretty much back to where we were. Yeah, so I think we had 16 people last time. Now we have 11, so 5 people missing, but there's no one messaging on the group, so I assume it's okay. Alright, so cool. Yeah, I think so, because it seems like Thelma and Benele have figured it out. It's crazy. Bryanston is the only school that's figured out teams. Doesn't work for Roosevelt, doesn't work for Crawford. But you guys seem to have gotten it pretty down. So yeah, sorry we tried to switch and caused all that trouble. Yeah, we'll stick to teams, because Benele and Thelma and everyone else looks like has also figured out teams. Okay. Cool. So let's take a break. Come back at 3:05. Okay, I'm going to start exactly at 3:05, and we're going to keep discussing inheritance and these other ideas. Okay. So yeah, see you at 3:05. added again, please? Hello. Keep yourself muted, please, Benede. Cool. Cool, shall we get started again, guys? Is everyone here? Ready, 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 ready. Good. Okay, cool, so it's this idea that we were thinking about, okay, the idea of inheritance. And we've already created now a rectangle class. So let's go ahead and program up this example. Okay, so we're going to create a polygon class. Our rectangle class is going to inherit from polygon, and our square class is going to inherit from polygon. Okay, so this way we'll have three, I guess you could say, three different classes, okay, three different types, but we'll only really have to fully program one of them. Okay, we'll only have to program one of them fully. All right. So, let me make sure some of you guys like following along in your textbook. This stuff is on page, it's somewhere pretty late in the section, I think. Values and references, encapsulation. Page 48. Page 48 this is on. Okay. Yeah, page 48. Alright, so let's do this. Alright, let's do this. Okay, so C#. Alright, here we are. So we've already created our rectangle class. I'm just going to leave that there for now. Okay, we're going to leave that there for now. And we're just going to create a polygon class. Okay, how will we create a polygon class? We just say class polygon. Correct? Class polygon. Not too bad. I think C# does this whole class thing very nicely, actually. It's quite logical. Cool. So our rectangle class, okay, is going to inherit from our polygon class. So how you write that in C#, it's very easy, very nice to read, actually. How you write it is you just say, okay, rectangle, so class rectangle, exactly like we had before. Then you just put a colon, okay, and you just tell it what class it inherits from. Exactly like that. So it's done. We now have a rectangle class that inherits from a polygon class. Okay, a rectangle class that inherits from a polygon class. Okay with that idea so far? Now what I'm going to do is I'm going to take the public double length and width. I'm going to remove them. Okay, so they don't exist inside rectangle anymore. Okay, they don't exist in rectangle. And I'm just going to put them in polygon. Like so. Okay, so now we have a polygon, okay, that has a length and a width. Okay, and those length and widths have getters and setters. All right. And we have a rectangle that has a constructor. All right. So let's see this. I'll show you what's happening here. Okay. So we have two classes, right? And we do actually have two. So I can show you. I'll say polygon. We'll call it poly, okay, or shape. Let's say shape equals new polygon. Okay, like so. Okay. When I run this, you see it works. It works. It allows me to create a thing of type polygon. Okay. It doesn't notice. I hope you guys did notice that I didn't specify anything here. Okay. Polygon has no constructor. Okay. It doesn't have a constructor. So I can't yet specify the length and width. In order to specify, so we've got a shape, it does have a length and width. I can show you that. We can say shape.length equals 6.0, for example. And if I go console.writeLine, wow, what is my typing today? Shape.length. Okay. You can see that this will work when it eventually runs. Okay, you see it prints out 6. So it's happy, okay? It does this. We've now created an object of type polygon, and we've set its length, and we can see the length, okay? So this does have a length and width property. Okay. No questions, cool. So what is inheritance allowing us to do here? You can see that in rectangle here, I don't define the length and width properties. Okay? You can see I don't say public double length gets set. You can see I don't do that here. Right? Everyone's comfortable with that? I don't create the properties inside rectangle. But because rectangle inherits from polygon, okay, rectangle inherits from polygon, length and width are defined over here. Okay, the length and width are defined over here. So I'll show you that. I've created this thing of type polygon, okay? And separately now, so I'm also going to create another object of type rectangle. Okay, so I can say rectangle. We'll call this rectangle rect equals new rectangle. And I have to give this 2 numbers, right? Because rectangle does have a constructor. And it requires me to specify a length and a width. So I'll go ahead and specify a length and a width. I'll say, let's say 10.0 and 3.0. Okay. And now, if I say console.writeLine rect.length, okay. Notice I did not define length inside rect, right? Remember that. I did not create the length and width properties inside rect, but you can see it still works. It still made length 10, and it will still make width 3. Okay. You see that? It's quite a cool thing, right? That it can actually see inheritance. So now, think about the structure we've created inside C#. We've told it what a polygon is. Okay, in our case, a polygon is just a shape with a length and a width. And we've told it that a rectangle is a polygon. Okay, and we've told it what's special about a rectangle. Okay, it's quite, and I want to show you that C# does understand this idea. So if you remember all our discussion about operators, right, like equals equals and less than or equals equals and equals itself, all of these operators, they had something on the left and something on the right. There is actually an operator that shows this idea quite nicely. Okay, there is an operator that shows this idea quite nicely. So I'm just going to show you that operator quickly. Okay, so I'm going to comment out the code we have here. Okay, so that will no longer run. It's just a comment. Okay, and I'm gonna show you what this new operator is, so that you can really appreciate the structure that C# has going here. Okay, so I'll say int x equals 6. Okay, that we're very used to by now. I'm just creating a variable of type int. Its name is x and its value is 6. Okay, where we understand what this is. We understand what this is. So what I want to show you is this operator called is. Okay, it's you can actually see if I type is, you see it's highlighted in blue. C# knows what this word means. Okay, so you can and what this word does is if you give it something on the left, okay, and something on the right, okay, if the thing you give it on the left is the same type as the thing you give it on the right, then this will return true. Okay, so you see int x equals 6, x is int. Okay, so when I run this, it says true. Okay, because x is of type int. If I say x is string, then it's going to return false. So you see what this is doing. If the thing on the left has the same type as the thing you specify on the right, then this returns true, and otherwise it returns false. Okay, so x is string, that returns false because x is an int. Okay, so this is quite a nice operator for showing this idea of inheritance. So what I'm going to show you is I'll create a rectangle. So you see here I created our rectangle rect. Rectangle rect equals new rectangle, and I gave it its length and width. Okay, so I can show you, I can say rect. Okay, we created rect, right? Rect is rectangle. Okay, we created the rectangle class, right? Before we created it, C# didn't know what this word meant. But now you can see it goes, yeah, that's true. Rect is a rectangle. Okay, I can also say, notice, all rectangles inherit from polygon. Okay, so rectangle inherits from polygon. So if I say rect is polygon, that's also true. Okay, because everything that is a rectangle is also a polygon, right? But if I create this polygon object shape up here, you see shape is a polygon. If I say shape is polygon, that also returns true, obviously. But you see if I say shape is rectangle, that's no longer true, right? That's no longer true. That's false. Because polygon doesn't inherit from rectangle. Rectangle inherits from polygon. Okay. So this is quite a cool idea. We've now basically explained the concept of polygons and rectangles. And let's see now why this is so useful, why it's so powerful. Okay, so we've got class polygon, we've got class rectangle, which inherits from polygon. But you saw in our slide over here, we didn't just have squares inheriting from rectangles inheriting from polygon. We also had squares inheriting from polygon. Okay, because squares also have a length and a width, right? So let's create that. We can say class square. And how do I tell it that it inherits from polygon? We just say colon polygon, right? Okay, so now again, I don't have to go and create length and width. Length and width are already created. Okay, and now I can say public, I want to create a constructor for my squares, right? Public square. Cool. Now, guys, so if we have length and width properties, let me see if you guys can answer this. It might require some thinking. Okay, we have these length and width properties. All right. Okay, so we needed two numbers, a length and a width, to create a rectangle. How many numbers do I need to create a square? Anyone got an answer? We needed two numbers to create a rectangle. How many numbers do I need to create a square? Right, we still have a length and a width, but how many numbers do I need? We need one. Okay. Okay, so hopefully, so I think Thelma gets it. Hopefully, Sachin, hopefully you get it. And you can see why that is. Why do I need one? Does anyone want to type out quickly why I need one? Maybe it might be a bit long to type. But the basic idea, the reason I only need one, is because, yeah, exactly. The length and the width are the same, right? The length and the width have the same value. So if I specify the length, then I already know the width. You don't have to tell me. Okay. So for a square, here we took in double L and double W, right? To get the length and the width. Here, I just need to take in double L, right? And then I just say length equals L. And I can say, either I can say width equals L, that would work, but also width equals length would work, right? Either way, I'm going to say width equals L. I think that's a bit clearer, but you can think about it in either way. The point is that the length and the width are the same value, right? But you see how much easier this was. I didn't have to go and create another, like I didn't have to go and create length and width again, or do any of this stuff. It all already exists, and now C# knows all squares are polygons, all rectangles are polygons. Okay, it knows these relationships. Okay, so now it doesn't just know that a square has two sides that are equal. It also knows that squares are kind of similar to rectangles in a way. If you say is square, like if we create a square and we use this is keyword, we say is polygon, it'll go yeah. If we give it a rectangle and we say is polygon, it'll go yeah. So if you were looking specifically for polygons, for example, you could use that is keyword and it would see both squares and rectangles as polygons. Okay, so it's defined quite a powerful relationship, and it was very easy for us to do, right? We've got all these different objects and we didn't have to reprogram a bunch. Okay, so it's quite a nice idea, this inheritance. Okay, so cool. All right, what do we want to see now? Okay, yeah, I think are you guys comfortable with this idea of inheritance? Obviously we want to create an object of type square now, right? So we created a polygon object, we created a rectangle object, okay, and we saw that rectangle automatically had length and width, okay, and we just had to define a constructor to set the length and width. The polygon doesn't have a constructor, so the polygon's length and width are undefined. Okay, we haven't set them. We haven't set the polygon's length and width, right? Because it doesn't have a constructor. Okay, and squares also have a constructor, and they also have a length and width, and we can just say square. Let's call it SQR equals new square. Okay. And this time we just give it one number, right? Like 20.0, for example, and it'll just go ahead and create a square with both a length and a width for us. Okay, so there we go. We've created these three different objects now, but they all have this weird relationship to them. Okay, they all have this relationship to them. Okay, cool. So I hope you guys get that. That's inheritance. That's the first concept sort of done. Now remember, I told you that inheritance was related to this other word, polymorphism. Okay, it sounds like a scary word. It's Greek, literally Greek. Okay, polymorphism, and they're sort of related to one another. Okay, so I first want to set up this idea, the idea that we're trying to address here. Okay, before we go into it. Okay, so currently one of the problems we might have in inheritance. Okay, what are the problems that we might have now that we've defined this concept of inheritance? Okay, let's explore that first. Okay, so you can see I've created this polygon shape, the rectangle and the square. Okay, so I've created these three classes. I don't necessarily want you to be able to create polygons. You see, I created a polygon here, a polygon object, but you see it has no constructor. So there's sort of this idea of, okay, how do I make it so that this class is, I'll tell you the word now. Okay, I'll tell you what these, all the words, again, it's going to be a bit of a flood, but hopefully you can put it together in your head. We would call polygon a base class. Okay, a base class, because it is a class that other classes inherit from. Okay, so rectangle inherits from polygon and square inherits from polygon. Polygon would be called a base class. It's a base, a foundation for other classes. Okay, so other classes inherit from it. We would call rectangle and square derived classes. Okay, because they're derived from this other class. Okay, they come from this other class. They inherit from this other class. So polygon here would be called a base class. Rectangle would be called a derived class. I'm just telling you all these words because these are the words that they'll use to refer to these things in tests. Okay. Cool. So we've got a base class. We've got our derived classes. Okay. How do I make sure that you can't create a polygon? Okay, because I've created polygon, but in our case here, polygons don't really exist. They don't have a constructor. Okay, they are just a concept. Okay, they are an abstract concept. That's the word we would use to refer to it. They're an abstract concept. Rectangles and squares are polygons, and polygons are just like this abstract idea. It's just something with a length and a width. But when you actually want to create a polygon, you have to choose. Is it either a rectangle or a square? Okay, in our case here, obviously there are other ones in the real world, but we can't program them all. Okay, so this next idea is, how do we define this? How do I say, okay, polygon is a class that can only be inherited from. You can't actually create a polygon. Okay, you can create a square or a rectangle, and it will also be a polygon, but you can't create a polygon directly. Okay, so how do I enforce that idea? Likewise, I could say rectangles are the most specific they can be, if you like. How do I say you're not allowed to inherit from rectangle? Okay, so like you can't have, so you see how we've inherited from polygon? Okay, how do I say you're not allowed to go and create another class that inherits from rectangle? Okay, how would I enforce those relationships? So kind of like the word public and private, except these words are referring to whether or not you can inherit or can only inherit. Okay, so like whether or not you're allowed to inherit from this, or if you're only allowed to inherit and not allowed to create it directly. Okay, so in the concepts of inheritance, we have this problem to grapple with. Okay, and it kind of extends into this idea of polymorphism. All right, so let me go to the next slide because I'm probably freaking you out with all these words, I imagine. Okay, and so there's two words here, and again, they mean what they sound like. Okay, abstract and sealed. Okay, these are still a part of, those two words are a part of inheritance, but we're going to extend this into a discussion about polymorphism as well. Okay, cool. So you now know why, maybe, or are getting to the idea of why we'll need abstract and sealed. Please mute your mic, whoever that is. Benele, you're here now still though, hey? Cool. Yeah, sorry your connection's bad, hey? Okay, so cool. Okay, we have these two ideas. What is polymorphism? Okay, just in terms of the meaning of the word, we'll get into it more specifically later. Okay, poly means many. Okay, it's Greek for many, and morphism or morph means form. Okay, so polymorphism just means many forms. Okay, and we'll get into more specifically what that means in this case as well. But essentially, you can picture of it of, okay, there's these things inside classes, properties and methods, and they can have many different forms depending on the class that they're in. Okay, that's why it's called that. Anyway, okay, let me get back to this focus. Okay, cool. So hopefully you recognize the structure currently. Okay, so we have a polygon class. Okay, that's our base class, right? We have another class, rectangle, that inherits from polygon. Okay, we could call this a derived class. Okay. Currently, and I can show you this in the code. Okay, if we come to the code quickly, we create an object of type polygon. We can also create an object of type rectangle. Okay, so we can create both of these objects. We also have a square here. Ignore that for now. It's not in our little diagram. Okay, but we can create these two objects, and that's what these arrows here are showing. Okay, you can create a polygon object, and you can create a rectangle object. Okay, so I want you to see what these words abstract and sealed mean. All right. So to show you that, if I made polygon abstract, okay, so that's what this is showing. If we made polygon abstract, then you wouldn't be allowed to create this polygon object. Right? Hopefully you're following. Okay. So here you can see I can create a polygon object directly, as if it was a square or a rectangle. Okay. Currently, because polygon is not abstract. If I make it abstract, then this creation of a polygon object, this line here, is no longer allowed. Okay, so I can show you that, and it's quite easy to show you actually. Again, most of this section is learning what the words mean. Hey, remember that. So if I say abstract, I literally just type abstract here. So now it's an abstract class. Okay, it's an abstract class. It's now going to complain about this line. You see, it says, cannot create an instance of the abstract class. Okay, so if you make it abstract, it means you cannot create an instance of it. You cannot create an object of it. Okay. So do we understand what the word abstract means now, guys? Are you comfortable with what the word abstract means? Not too complicated, right? If I made rectangle an abstract class, this would not be allowed. You would not be allowed to create something of type rectangle. Okay, happy with that idea? Okay. So you see currently, because polygon is abstract, I'm not allowed to run this line. If I make it not abstract, so I just remove the word abstract there, then it no longer complains. It allows me to create the polygon. Okay, it allows. You see, no errors. Okay, so that's what abstract means. Are we happy with that idea? Any further questions? It's not a complicated idea, right? If you say abstract class, that means you're only allowed to inherit from it. Okay, you have to inherit. You cannot create an object of that class directly. And you can see the word abstract makes sense there, right? It's defining an abstract concept, an abstract idea, rather than an object, like things that can actually, like a concrete thing. Okay, cool. And sealed is kind of similar to this, right? So let me show you what sealed means. Okay, so we go back to this example where polygon is not abstract. So currently we can create the polygon class and we can create objects of it. From polygon we can inherit from it and create rectangles, and we can also create rectangle objects. Okay, so what would sealed mean? If I make the polygon class sealed, then that means you're not allowed to inherit from it. Okay, that would mean you're no longer allowed to say a rectangle inherits from polygon if polygon is sealed. Okay, so this all becomes impossible. Okay, you wouldn't be allowed to create this rectangle object if polygon was sealed. Okay, so now I can show you that if I say, and it's literally just the exact same as when I made it abstract, you just type sealed here. Ooh, sorry, I pushed insert. Sealed class polygon. Okay, so now you can see I'm going to comment out the rectangle line. It's not going to complain about this. It's going to complain about this. Okay, so if I try to run this, you see it says square cannot derive from sealed type polygon. Rectangle cannot derive from sealed type polygon. Okay, so it's complaining. It's saying rectangle and square cannot inherit from polygon because it is now sealed. So in this case, what we might want to do is say, okay, polygon is abstract. You're only allowed to inherit from it. Rectangle and square are sealed. You are not allowed to inherit from them. Okay. Ooh, sorry. Oh, right. That's because I'm still trying to do this. Okay, because polygon is now abstract, you're not allowed to create a thing of type polygon. So we stop doing that, and you can see everything works now. Okay, so polygon is abstract. You're only allowed to inherit from it. Rectangle and square are sealed, so you are not allowed to inherit from them. Okay, so that's just what those words mean. And those things, so if you know what inheritance means this, okay, that you can inherit from polygon, all right? And so you know what inheritance means. You know that an abstract class is a class that can only be inherited from. You know that a sealed class is a class that cannot be inherited from. If you know those three ideas, then you understand inheritance. Okay, that would bring us to the end of that first topic, inheritance. Okay, so you guys okay with inheritance? No more questions about abstract and sealed. Awesome. Oh, that's very good. Cool. The next idea we want to talk about is polymorphism. Okay, so currently you know that polymorphism means many forms. Okay, that's what you know. So maybe in your head you're picturing like, okay, I can define these properties and methods inside my class, and in other places they can have many different forms. Okay, let me also just find where this is in your book, because it might be good for you to see it more specifically. You can kind of see it on page 50 and 51. But yeah, their primary example is on page 54. Okay, but the only word we really need to know from polymorphism is the word override. Okay, override. You guys can sort of maybe picture what the word override would mean. It means, okay, you have this you have this base implementation of something, a base implementation of something, and you can override that implementation, so you can alter it later. Okay, you can alter it, so change it in like a fundamental way. Okay, so even though it has a thing already, instead of using that, you can override it. Right, so this is the only word we really need to know from polymorphism. Okay, and just generally maybe what polymorphism does. Okay, so let's set up our polymorphism example. Okay, so hopefully we understand the concepts that are going here. We have two sealed classes, rectangle and square, and they are what we call derived classes. So we can say that square and rectangle derive from polygon or inherit from polygon. And we have our base abstract class polygon that just defines a length and a width. Okay, so let's do something interesting here. So we've got a rectangle here, okay, and it has a length of 10 and a width of 3. Cool. I'm gonna go and create a square object as well, and I'm allowed to create a square object, right, because it's sealed. Okay, it's sealed, it's not abstract, so I'm allowed to go and create a square, new square. Okay, and we can make this, let's say, 5.0. Okay, so its length and width are 5.0. And we're happy that that will work. Okay, so we've gone and created two objects. All right. Now, what if I want to calculate the area of my rectangle? Okay, so it has, maybe we can just print it out. So we can say console.writeLine. Okay, it's rect.length. Okay, that will print out its length, which is currently 10. And we can also go console.writeLine rect.width. Okay, I just want to multiply these two numbers together, basically. Right, in order to calculate. Okay, so we've got 10 and 3. I want to multiply these two numbers together in order to calculate the area. So I could do that here. Yeah, I could do that here by just saying the little asterisk means multiply, right? Asterisk means multiply. We can just say rect length times rect.width, right? That would be one way of doing this. Okay, and it gives me 30. That's correct. That's the area of our rectangle. Okay, but actually, this should be done in a method. Ideally, I should just be able to say rect.area. Right? Because what if I go and create a second rectangle now? I'd have to go write this all out again. Right? So actually what I want to do is create a method inside rectangle that'll allow me to calculate the area. So that method just needs to take the length and multiply it by the width and then return the value that it gets. Right? That's all this getArea function has to do. So let's create that. It's gonna be public because I want to be able to call it from outside of the method. So we'll say outside of the class. So we're gonna say public. Let's just call it area. Okay, area. Okay. I've missed out something here. What value? What type? You know, all our methods. This is gonna return something. It's gonna return the area, right? What type will the area be? Any suggestions, guys? What type should this method return? What type should this method return? Okay, we're going to multiply two numbers together. The two numbers are doubles. What should our method return? Any suggestions? Anyone? Anyone? Double. Okay, good stuff. Our method is going to have to return double. Okay, public double area. And what is our method just going to do? Okay, what is our method going to do? It's going to say double area. Okay, just create a variable called area. We're going to times length. So we're going to say length times width. Okay, and then we just return area. Right? Just return area. And now, when I want to calculate rect's area, I'll just say, instead of all of this stuff here, I can just say rect.area. Okay, and if I run that, you can see that eventually when it does run, it returns 30. Okay, so that works. That'll go and calculate the area. And any rectangle I create, so if I create rectangle rect2, rectangle rect2 equals new rectangle, and we'll give this one a length of 20.0 and a width of 25.0, okay. If I just say rect2.area, it'll now, right, left out the semicolon, most common mistake by far. It'll go and it'll calculate the area, okay, of rectangle 2. Okay, so as many rectangle objects as I create, I can calculate the area like this. Okay, which is quite cool, right? So, cool. But, I mean, what if I will now want to calculate the area of the square, right? It'll be 5 times 5. The area of my square, I should be able to just go square.area. Square.area. Will that work? No. No, it won't work. You see, it won't work. Why won't it work? Because we've defined area inside rectangle, right? Here, this is rectangle, our class rectangle. We've defined area here. Our class square has no concept of rectangle. I mean of area. It inherits from polygon, and polygon doesn't have area. So what if I go and just move this? I control exit from rectangle, and I put it inside polygon. Okay, so I go here and put area there. Okay. Run that. And it gives me 25. So now we've got this method that works in rectangle and it works in square, and I didn't have to redefine it, right? I just put it in polygon. Okay, and both square and rectangle inherit from polygon, which is quite cool. Okay, so we defined the method once, but it works for squares and rectangles. Okay, because all it's doing is multiplying the length times the width. It doesn't matter that the length and the width inside the squares are the same, right? In this case. Cool. So now I can calculate square.area, but I can also calculate rect.area. Okay, so they're now, what I want you to see is that now these classes are no longer inheriting just properties, right? So previously we were inheriting length and width, just properties. Now rectangle and square are also inheriting a method, right? They're inheriting area. Okay, they're inheriting this area method. Okay, they're inheriting the area method. You see that? So we can inherit properties and methods. And this idea of polymorphism, and particularly that word I mentioned, that word we need to know, has override. It has to do with methods. Okay. Again, this stuff is on page 54 around. Okay. Page 54. Yeah. Okay. So, let's see what override does. Let's see what override does. Cool. So as we mentioned, we said that this it's a bit silly, but you can picture if we had like a triangle class, then how to calculate area for a triangle is different. It's not just length times width, right? So in some scenarios this would be quite necessary, but here, just as a silly example, you can see in our area calculation we take length times width, right? What if for the square I actually just wanted it to be length times length? Okay, I wanted to take length times length instead of length times width, because in the case of the square it's equivalent. How we could go about doing this is with the word override. Okay, so we say public override double area. Okay, we're gonna have to make area abstract eventually to make this understood, but for now let's just work with this. Okay, and this is just going to return length times length. Okay, because in the case of the square it's the same thing. Okay, it might complain. Yeah, okay, cannot override inherited. Yeah, okay, cool. So what I'm going to do is there's two important words that we already know one of them. Okay, So remember what abstract means? It means I can only inherit from it, right? I can only inherit from it. Now, we've seen how classes can be abstract. We've seen how classes can be abstract. Methods can also be abstract. Okay? Methods can also be abstract. What it means for a method to be abstract is that it provides no implementation. So what do I mean by that? You see the code here, double area equals length times width, return area. That's what we would call the implementation of the area method. Okay? With a abstract method, you're not allowed providing that implementation. Okay? Cool. You're not allowed providing that implementation with an abstract method. And what you have to do is when you inherit from the abstract class that your abstract method is in, you provide the implementation there, like I'm doing here. Okay, just like I'm doing here. Okay. There is another way to handle this, which I'm actually going to show you first, and it's to do with the word virtual. Okay, I know it's a lot of words, guys, so you have to just revise what the words mean. Okay. So virtual means it's similar to abstract in that you can override it, but you're also allowed to provide an implementation. So let me just quickly change it to virtual just so that you can see what that does. Okay, you see now it works. Before it was complaining. Look, if I make a public double area, it complains. It says, no, you cannot override it. You cannot override the method area, because you see here when I was creating the method, I was saying public override double area, and I'm changing it from length times width to length times length, right? It's saying you're not allowed to override it because it's not virtual or abstract. Okay? It's not marked as virtual or abstract. Okay? If I mark it as virtual, then I'm allowed to override it and provide an implementation. Okay? I'm allowed to override it, so it's still, because I haven't overridden it in rectangle. Okay, so in rectangle it's still length times width, and you can see it still works. It goes 10 times 3 for the rectangle. But inside the square, it goes length times length. Okay, because it's allowed to override it because it's virtual. Okay, so that's what the virtual means. It's marking the method as allowed to have an implementation, but also allowed to be overridden. Okay, the other word, and this one's more important, I just wanted to show you virtual, it probably won't come up, okay? This one's more important. What happens if I mark the method as abstract? Okay, now when I run this, it breaks. Okay, so it says polygon area cannot declare a body because it is marked abstract. Okay, cannot declare a body. Okay, cannot declare a body. So I have to remove all of that. Okay, so now you see area, it almost doesn't exist. It does exist, but now all it's saying is, okay, the abstract class polygon has a method called area. Okay, so all polygons have a way to calculate their area. That's what it's saying. But polygon is no longer telling you how to create the area, how to calculate the area. So it's saying when you create a polygon, there is this abstract type method called area. Okay, you have to tell it how to calculate the area. When you inherit from the polygon class, you have to tell polygon how you calculate the area for this new class you're creating. Okay, it won't tell you how, but you have to tell it. It says, you can see, because now in square I provide an implementation for how to calculate the area of the square. Okay, I say public override double area, return length times length. But inside my rectangle, I don't tell it how to calculate the area, right? I haven't told it how to calculate the area of the rectangle. So this area method, okay, you have to explain how to calculate the area when you inherit from polygon. Okay, so this is now why it's complaining. It says rectangle does not implement inherited abstract member polygon.area, which is a complicated way of saying it, but you can see we've got this abstract method area, and rectangle hasn't defined it, and square has defined it. Okay, so what do I need to do? In rectangle, I need to tell it how to calculate the area of a rectangle. Okay, so I just put the method there, public override double area. I say that to calculate the area of a rectangle, you say length times width, and now it'll work. 30 times 25. I mean 10 times 3, 30 and 25. It returns for the rectangle and the square. Sorry about that. Okay, so you see, when you make an abstract method, basically, okay, let me say what we need to know about polymorphism. Okay, you can define a method in a base class, okay, and that method, the same method, it's still called area, the same method can take on different forms, right, many forms, in all of the derived classes. Okay, it's a bit of a difficult concept to explain, but I hope, are you guys comfortable with it? It is a difficult concept to explain, but that's why polymorphism, it means many forms. So you can see area, we've got this method area, and in rectangle it has a certain form, okay, length times width, and in square it has a slightly different form, length times length. Okay, so the area method is taking on many different forms. Do you get that idea? Are you guys comfortable with that idea? And that's what polymorphism is. And the important word with polymorphism is this word override. Okay, override. So you can override abstract and virtual methods. Okay. I know it's a lot of words. That's why this lecture is a bit hectic, but it's the only way to do it, right? There's a lot of words to get through, and we just have to learn the meaning. You're learning a new language, basically. Okay. So, yeah, are you guys comfortable with this idea of polymorphism? We've got this area method, and it takes on many different forms in many different classes. Okay. And that would bring us to the end of polymorphism. There's one more idea called encapsulation. One more idea called encapsulation, but we can save that for now. Yeah, I'm also actually feeling tired, but so yeah, we can save encapsulation. It is almost 4 o'clock. I don't want to. It'll only be one more word. For encapsulation, we just have to learn one more word. We do have 5 minutes. It's just one word. Although, no, it's maybe a bit difficult to grasp, so we will save it. We'll save it. Okay. So yeah, that brings us to the end of this week, guys. I don't know, maybe you guys should watch this lecture again, because I will be uploading it to YouTube as usual, of course. And yeah, so maybe do go through this video again, because there are a lot of words, right? It is a lot of words to remember. Okay, let me just go through the words that we're supposed to know quickly, okay, because we do still have 4 minutes left. What words are we supposed to know? We know what a constructor is. We know what getters and setters are. We know what private means, what public means. Okay, we know what inheritance is. Under this concept of inheritance, we know what abstract and sealed mean. Abstract means it can only be inherited from. You cannot create an object of it directly. Okay. Sealed means that you cannot inherit from it. Okay. And then we also learned about polymorphism, and that was the word override. Okay. So polymorphism means many forms. So a singular method can have many different forms in different classes. Okay. Those are all the words we learned. It's actually not too bad once you... It's similar to a normal language, right? It's a bit of vocabulary, basically. This is just what all these words mean. Okay. Those are the words that you should know by now. Okay. And obviously also know what a class is. And a namespace, and a method, and a property. But hopefully those words are easy for you by now. Okay. Cool. Yeah, thank you guys. So yeah, we'll stick to Microsoft Teams. Sorry about the bit of the hassle we had switching today. It was just because, I don't know, I was worried that some students weren't able to access through Teams. But I think, yeah, with Bryanston, we'll just stick to Teams. Why, sir? Wait, why, I'm sorry about switching to WebEx, are you asking? Oh, because, I don't know, it was just a bit of a hassle, because, like, most students couldn't make it onto the WebEx Meets one. So I don't know if it was a bit of an inconvenience creating all those accounts. But yeah, we'll stick to Teams from now on, because it seems to be working for most people now. So that's good. Yeah. Okay, cheers everyone. Enjoy the rest of your week, and see you next week at 2. Okay, at 2. But I'll post a reminder on the WhatsApp group, and I'll post this video to YouTube right now. Okay. Cool. Bye-bye, guys. Bye-bye.